All right, I accidentally clicked something that turned off the recording, so let's just restart number 6. We are given this equation. It has a graph, but we don't really know what it looks like. So we're just going to have to use principles of calculus rather than our intuition. So at first it says to show this about the derivative. They're already showing us something about the derivative. And what we want to remember is if we're given something of this form and asked to take a derivative, implicit differentiation is our only reasonable shot. So they're basically saying, without saying it, do implicit differentiation, but they're telling us what the answer should be. So if we make a mistake, we should be able to catch it. Right? They're already giving us the answer, but we want to go through the steps. So what we can do is we can start with this, and we can say, all right, let's take the derivative of the left-hand side. So I am going to structure this as 6x times y and use the product rule. So derivative of the first times the second plus the first times the derivative of the second. And then on the right-hand side, 0 plus derivative of y cubed requires chain rule, 3y squared times dy dx. We need to remember that y is a function of x in this context. So we have 6y. Well, let's just write this clearly and then clean it up. 6y plus 6x dy dx equals 3y squared dy dx. We want to isolate dy dx, so let's get both of those terms on the same side. Oops. And we can factor it out, so it's written only once. We have 3y squared minus 6x. So that means if we divide dy over dx is 6y divided by 3y squared over minus 6x. And we might notice that's not what is here, but hey, everything's divisible by 3. So we just divide by 3, and we're good. Right? Writing that check mark is not a bad idea. We're confirming, yes, the thing you told me the derivative was, that is the derivative. Okay, now find the coordinates of a point on the curve at which the line tangent to the curve is horizontal, or explain why no such point exists. So again, we don't really know what this looks like. We're going to need to use principles. And I know that if there is a tangent line that is horizontal, that means dy over dx is equal to 0. So horizontal tangent, let me communicate that fact. Maybe that'll get me a point in case I make a mistake on the computation. Horizontal tangent means dy over dx is equal to 0. So what that means is 2y over y squared minus 2x is equal to 0. And a fraction is only 0 if y is equal to 0. Now it is not asking me just for y, it is saying find the coordinates of a point. So I'm not done until I know an x-coordinate. So we'll go back and we will look at this. Here is the equation of the curve. So if y is equal to 0, this means 6x times 0 is equal to 2 plus 0 cubed. And this is basically saying 0 is equal to 2. So it's impossible to solve for x. So we can say there is no point xy on the curve with dy over dx equal to 0. Right? I tried to figure that out. It told me y is equal to 0, but if y is equal to 0, there's no corresponding x value. Okay, now find the coordinates of a point on the curve where the line tangent to the curve is vertical. A vertical line has no slope. So, right, let's say that. A vertical line has no slope, has undefined slope, however you want to say that. So what that means is, since dy over dx is 2y over y squared minus 2x, the only way this is undefined is if the bottom is 0. So we want y squared minus 2x to be equal to 0, which means 2x is equal to y squared. This is simply telling us the relationship between x and y. We still don't have a point, but let's go back to this equation. 2xy equals 2 plus y squared. Let's actually isolate y, so we'll say it's 1/2 y squared. Let's see if we can solve this. So we would have 6 times x, which is 1/2 y squared, times y is equal to 2 plus y squared. So this means 3y cubed is equal to 2 plus y. That should have been a cubed or a squared. Did I miscopy it? It should have been a cubed. Okay, let's fix that. Only differences here. And what that means is if we subtract y cubed from each side, 2y cubed is equal to 2. So y cubed is equal to 1, and y is equal to 1. Now we have a relationship between x and y. Once we know one of them, we can find the other. So x is equal to 1/2 y squared equals 1/2. So let's just make sure we're answering. The point with a vertical tangent is the point where x is 1/2 and y is 1. This is worth 3 points total. Basically 1 point for setting that denominator to 0, 1 point for getting to y equals 1, and 1 point for figuring out x. Something like that. All right, last bit. A particle is moving along a curve at the instant where, along the curve, right? So this same curve, but now we're imagining motion. At an instant where the particle is at the point 1/2 comma -2, its horizontal position is increasing at this rate. So it's moving, x is increasing at the rate of 2/3 of a unit per second. What is y? What is dy dt? So these are rates as things change according to time. So we want to do this as a related rates problem. So we're going to, I think it's easier to just kind of redo some of this. There is a slicker way to do this, but let's just go back here. And instead of thinking about slopes, let's do this as though it's a related rates problem. So let's take the derivative of everything with respect to x. We already know how x and y are related. So I'm sorry, I misspoke. Let's take the derivative of everything with respect to time. Right? We will differentiate with respect to time. There is a shortcut for doing this problem using what we've already seen, but I think it's better if you have, unless you're really panicked or understand the shortcut easily, I think it's better to just do this as a related rates problem. It'll be similar to what we did before. So here's the derivative of 6x with time as the variable times y plus 6x times the derivative of y with time as the variable. And then the derivative of y cubed is 3y squared times the derivative of y, which is dy dt. And now we can plug in dx dt equals 2/3. So 6 times 2/3, and we can plug in y equals -1/2. So we have all of this stuff we can plug in. Plus 6 times 1/2 times dy dt equals 0 plus 3 times -2 squared times dy dt. So what do we have here? 6 times 2/3 is 4, times 2 is -8. This is 3 dy dt. Negative 2 squared is 4. 3 times 4 is 12. So we can group the like terms. We would have 9 dy dt. And so dy dt is equal to negative 8 over 9. And there we go. That's the end of the free response.